Hello and welcome back. So we are in chapter Electricity of your 10th class and this is your lecture 2. In this lecture we are going to discuss about current. So this entire video is about current. So before learning this concept, we need to have an idea about what is meant by current. So in general, meaning for current is flow. So whenever you see the word water current, simply we can say it is a water flow. Whenever you observe air current, you can say it is air flow. And we are in chapter electricity. So what current we need to learn? We need to learn about electric current. Okay, let us try to understand what is meant by electric current and what causes electric current. You see, before learning about electric current, you need to understand few concepts and relation between that. Conductor. What is meant by conductor? Conductor is a material which allows electricity to pass through it. Then battery. What is meant by battery? Battery is combination of two or more cells. And you need to learn about free electrons and movement. What is free electron? Electron which is free in a conductor, which is not revolving in orbit, which is outside of the orbit of an atom, is called free electron. What is meant by movement? Yeah, it is motion. So here you need to understand the relationship between all these. You see, in conductor there will be free electron. All free electrons will be in motion, and this movement, this motion is caused because of battery. So try to understand this flow chart. Conductor is a metal which allows electricity to pass through it, and all conductors will have free electrons. So free electrons will be in motion. There will be movement in free electron. That movement is caused because of battery. Next, electric circuit. What is meant by electric circuit? There is a definition for that. A continuous and closed path of an electric current is called electric circuit. You see this? This is a sample electric circuit where you can find battery. Here it is battery, and this is bulb. Here we have key, and we'll talk about ammeter. This A represents ammeter. So for what this ammeter is used, that we will learn after some time. This is a simple electric circuit and it is closed. In last lecture we have learnt about open circuit and closed circuit. This is an example for closed circuit. In a closed circuit, electric current is passed. Next, Drude and Lorentz, both are scientists of 19th century. They told that conductors or metals contain large number of free electrons. So because of free electrons, conductors conduct electricity. That is a concept we have learnt in our previous video. Here, positive ions are fixed. Positive ions are fixed in their locations, and the arrangement of the positive ions is called lattice. Of course, this concept is not there in your 10th class CBSE textbook, but try to understand the concept. So in conductor, all positive ions are fixed. That fixed position is called lattice. You can observe this diagram where conductor and all those rose color particles are free electrons. You can see the random motion of electrons in open circuit. We have two types of circuits, open circuit and closed circuit. These are free electrons in conductor of open circuit. And in middle you can observe that is area of cross section. Any area you can consider that is an area. Next, you see those red color particles are atoms, or simply to say positive ion, and those positive ions place is fixed. That fixed place is known as lattice, and those blue color particles are free electrons which are in random motion you can observe. So by this diagram what we can understand, when the electrons are in random motion, they can move in any direction. They can move towards left, towards right, upwards, downwards. In random motion, all those electrons will be moving. If you imagine any cross section, so any point inside the conductor, the number of electrons crossing the cross section of a conductor from left to right in 1 second will be equal to that of electrons passing the cross section from left to right in 1 second. So consider in a conductor there are 20 electrons crossing from left to right, same 20 electrons will be crossing from right to left, so that net flow rate is 0, so that in open circuit current is 0. You can see that electron cloud in metal, so that silver colored particles are atoms, simply to say positive ions, and those red dots which are moving randomly, those are free electrons. You can observe motion of the free electrons is random. It is moving towards right, left, upwards, downwards, and number of electrons which is passing from left to right is equal to right to left, and top to bottom is equal to bottom to top, so that net current is 0. Behavior of electrons in lattice space. This is a conductor in which we have taken one cross-sectional area. That dark patch in middle of the conductor is area of one cross-section. There you can see how electrons are moving. That arrow marks representing motion and direction of free electrons. Some electrons are moving towards right, some electrons are moving towards left, some are going up, some are coming down. So number of electrons crossing left to right and crossing right to left will be equal, and this motion is known as random motion of electrons. This is possible only in open circuit. What happens to the motion of electrons when the ends of conductor are connected to the battery? So if you connect both ends of conductor to battery, what will happen to the electrons? Till now we have discussed without connecting battery, but now we need to discuss by connecting battery in a circuit. So if you connect, what happens? If you keep any bulb, that bulb glows. Why that bulb glows? Energy transfer takes place from battery to the bulb. Here, the electrons are responsible for this transfer of energy, and battery we are using that is producing some energy, and that energy is utilized by free electrons to move in a circuit. You can see the diagram where we have a bulb, battery, and conductors are connected. From battery, energy is produced. Because of that energy, all free electrons inside that conductor will move and reaches to the bulb, and bulb glows. Like that, battery works. And we need to discuss about ordered motion. Till now we have seen random motion. Now this is ordered motion. You can observe all electrons inside that conductor are moving towards right hand side from left hand side, and all electrons are in ordered motion without any deviation in its path. So you can observe this diagram. So the silver color particles are positive ions, or you can say atoms, and those green color particles which are moving, those are free electrons, and all electrons are in ordered motion. Then electric current. What is the actual definition for electric current? Electric current is defined as the amount of charge crossing any cross section of the conductor in 1 second. This happens in ordered motion, not in random motion. So amount of charges in the sense free electrons, amount of charges crossing any cross section. So if you take any area, how many electrons are crossing that area in 1 second, if you calculate, that is meant by electric current. In simple words, what is meant by electric current means flow of electrons. That's it. And let Q be the charge crossing through any cross section of the conductor, and in time interval T, charges should be represented with the letter capital Q, and the time should be represented with small t. By this we'll get a formula: electric current is equal to electric charge upon time interval. So what is the meaning for that formula? Electric current is equal to electric charge by time interval. So if you see meaning of that formula, number of charges flowing in a conductor in particular time is called electric current, and electric current is represented with the letter I, which is equal to capital Q by small t. Capital Q represents electric charge, T is time interval, and the SI unit of electric current is ampere, which is denoted by letter capital A. Ampere is scientist name, so that should be represented with capital A. And if you want to write full name, that should be in small case. So scientist name should be written like that. And electric current we can measure. Quantities which we can measure is known as physical quantity. Electric current is also a physical quantity, so we have SI unit for that. Here, how to define 1 ampere? 1 ampere is equal to 1 coulomb by 1 second. Here you can observe ampere is SI unit for electric current, coulomb is SI unit for electric charge, and second is SI unit for time. So how to define 1 ampere? 1 ampere is nothing but 1 coulomb of charges flowing in a conductor in 1 second is called ampere, and short representation 1A is equal to 1C by 1S. 1 ampere is equal to 1 coulomb by 1 second. The SI unit of electric charge is coulomb, that should be represented with the capital C. Coulomb is also a scientist name, which is equivalent to the charge contained in nearly 6 into 10 to the power of 18 electrons. 1 coulomb is nothing but 6 into 10 to the power of 18 electrons. I mean group of those many electrons, nothing but 1 coulomb. So you can keep 18 zeros beside that 6 and you can count how many electrons will be considered as 1 coulomb. So 1 coulomb is not a small amount, it is very big amount. I told you electric current can be measured and it is physical quantity. How can we measure electric current? We have a device called ammeter. Ammeter is used to measure electric current, and you can see diagrams of ammeter. There are two terminals, positive and negative. Red always represents positive, black represents negative. So ammeter is always connected in series to the circuit. We should not connect in parallel. Why we should not connect? An ammeter is connected in series always with the circuit because the purpose of ammeter is to measure the current through the circuit. So we need to measure total current in the circuit. Since the ammeter is a low impedance device, connecting it in parallel with the circuit would cause a short circuit or damaging the ammeter. We have another reason, of course, the same. The purpose of using ammeter is to measure the rate of current flowing through it. So in any circuit, if you want to calculate amount of current flowing, you need to use ammeter. Hence, to make the measurement possible, the whole current has to flow through the coil of the ammeter. So if you want to calculate total amount of current should flow through the ammeter. This is why ammeter is connected in series. The ammeter coil is designed to offer very less resistance to the flow of circuit. We have few questions. Why do electrons move in specified direction? Second question. Before reading that second, we will see this. When the conductor is not connected to the circuit through a battery, so we consider there is no battery, then the electrons inside the conductor are in random motion. So this we have learned in the beginning. When there is no battery, there will be no energy. When there is no energy, all electrons will be in random motion. When the conductor is connected to a battery, what will happen? The electrons move in a specified direction. So in a circuit, if there is no battery, we can get random motion. If you connect a battery, there will be ordered motion. You can observe in first diagram, those electrons are in random motion. In second diagram, cell is connected between two terminals, so automatically you can observe ordered motion. So you can observe that. Next, when the ends of conductor are connected to the terminals of a battery, what will happen? You see the diagram? There is small cell where conductor is connected. Here, when battery is connected, automatically a uniform electric field is set up throughout the conductor. So inside that conductor, there will be uniform electric field. When you take magnet, there will be magnetic field. If you take cell and conductor, there will be electric field. This field makes the electron move in a specified direction. Because of this electric field only, all electrons will be moving in specified direction. If there is no cell, there will be no electric field. If there is no electric field, there will be no ordered motion. If there is no ordered motion, all electrons will be in random motion. So try to understand that concept. So we have few questions I told. In which direction do the electron move? Do the electrons accelerate continuously? Do they move with a constant speed? These three questions are to be answered. So, in which direction do the electron move? Is there any specific direction for electrons? And will be there any acceleration for electrons? And at the same time, is there any constant speed for electron? Let us try to answer these questions. So the free electrons in the conductor are accelerated by the electric field. Answer is yes, there will be acceleration for free electrons. Why there will be acceleration? Because of presence of electric field. So electrons move in a direction opposite to the direction of a field. So electron direction is opposite to the direction of electric field. Electric field direction, electron flow direction will be in opposite. You see this diagram, we have battery, bulb and conducting wire. So here two things we need to learn: flow of electrons and direction of current. Always remember, flow of electrons will be from negative terminal to positive terminal. Already we have learnt in our previous lecture. Near negative terminal, free electrons are generated that will flow throughout the conductor and reaches to positive terminal. And while coming to direction of current is opposite to the flow of electrons. Now what is the direction of current? It is from positive to negative. In the diagram you can observe arrow marks with red color and black color. That red color direction is flow of electron from negative to positive. That black arrow marks you can observe from positive to negative. Right? So what you need to remember? Do we need to remember flow of electron direction or direction of current? You must remember only direction of current, that is also known as conventional current. You can observe this diagram where electrons are flowing from negative terminal to positive terminal. So electron flow is taken from negative to positive, but conventional current, I mean direction of current, you have to take from positive to negative. Don't get confused. You can observe in this diagram, this is closed circuit. This is how electricity works. All electrons, free electrons, charges will be in motion. So from battery, charges are generated that flows through conductor, reaches to bulb, bulb glows, again remaining electrons will enter into the battery. When electrons are in motion under the influence of the field, what will happen? They collide with lattice ions. So when electrons are in motion, there will be some collision with lattice ions. Lattice ions in the sense positive ions. What happens to the electrons? Automatically they lose energy. Electrons lose energy and may even come to halt at every collision. So electron will be in motion, hits positive ion, that will lose energy and even come to halt. Again, they are again accelerated by the electric field. Electrons are accelerated by the electric field and then make collisions with other lattice ion. So it will move, collide, come to rest, again gains energy, move, collides, lose energy, comes to rest, again accelerated by electric field. This will be circular, and this way they continue to move along the conductor. So every time electrons will be in motion, that will hit particles, that will collide with positive ions, that will come to rest, again it will gain energy, it will move forward. So like that it will be moving on. By this we can say, you can observe all positive ions are at rest, which is known as lattice, and all electrons are in random motion. Now if electric field is created, if you connect battery, you can observe all electrons will be moving from left hand side to right hand side, right? So like this, electric field is set up and all electrons will be in motion. So this is the explanation for that. There will be an electron which moves downwards, upwards, left hand side, right hand side. It will have greater collision and it will be continuing its journey inside the conductor. So hence we assume that electrons in the conductor move with a constant average speed. So we need to calculate its average speed. We have to consider its speed as average speed because there will be motion, there will be collision, it comes to rest, again gains energy, again will be in motion. So we cannot calculate every time, so we'll consider it as average speed. This average speed is known as drift speed of an electron or drift velocity of an electron. Here, let's solve a small numerical problem. You see that question. A current of 0.5 amps is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit is the question. Now, solution for that. What are given for us? They gave current I is equal to 0.5 amp and the time it is in 10 minutes, but we have to consider all units in SI system. So try to convert 10 minutes into seconds, it becomes 600 seconds. So now we have data I is equal to 0.5 amp, time is equal to 600 seconds. All units should be in SI system. We know a formula of current I is equal to Q by T. So electric current is equal to charge by time. In question what he asked, find the amount of electric charge. So we need to find Q. We have I, we have T, try to find Q. So here if you observe the formula, T is dividing, if it goes that side, it will multiply with I, it becomes Q is equal to I into T. Try to substitute, that is equal to I value 0.5 amp into T value 600 seconds. So 0.5 is nothing but half. What is the half of 600? Yeah, it is 300 and Q value is 300. What is the SI unit for charge? It is Coulomb. Answer, Q is equal to 300 Coulomb. Like that you need to solve numerical problems related to current. Now, one small concept. You see, there will be a body which is at rest. Consider that body is at A. Now, you need to move that body from A to B. Body is at rest, but you need to make that body to move from A to B. What will you do? Yes, just you will apply some force to that. Now try to apply same concept on electron. Consider in a conductor there are electrons. Let us consider only one electron inside the conductor. Now this conductor is at rest. Now that conductor should move from one point. Consider from A point, here there is a bulb. That point is at B. Now electron should move from A to B. So electron is at rest. We have to set that electron in motion. What we have to do? We should apply force to that, isn't it? So where do the electrons get energy from for their motion form? So if electron wanna move in a conductor, there should be some energy, isn't it? Who will give that energy? What will produce that energy? That we'll discuss in our next lecture. So students, if you like this, please like this video, share, comment and share these videos to all your friends such that they will also learn and they gain some knowledge. And please subscribe to this for updated, latest and informative videos. Thank you.